Okay, these are the solutions to the Math 3 Unit 3 practice test. Number 1, given p of x equals -1/2 times x plus 3 squared times x minus 1 times x plus 4. The following terms represent solutions. Which of the following terms represent solutions of p of x equals 0? So this is saying p of x is equal to 0, so we want to plug in 0 for p of x. All right, solutions are when I would solve for the x values here. And once I solve those solutions, I'm going to get certain points on my function. So if I draw in my function here, well, if I know that the entire equation is equal to 0, then I know these things multiplied together have to also equal 0. So you set each one equal to 0. And I can find my solutions a couple different ways. I know that I can plug in an x value, and whatever x value that makes the statement true would be a solution. So if I plugged in -3 here, -3 plus 3 is 0, 0 squared is 0. So x equals -3 would make this statement a true statement. Same thing here, I could plug in a +1, or I can actually solve for x by adding 1 to the other side. Either way, you get x equals a +1. And adding 4 to the other side would give me x equals +4. So we have a polynomial of the 4th degree, because this is x squared times x times x. And it opens, both end behaviors go down because it's even, and we know even goes in the same direction, and the leading coefficient is negative, so that means the right side goes to -infinity, which means both of them have to go to -infinity. So I know a couple different pieces of information. First of all, solving for an x value like this is called finding the 0 of the function. That's why we set each of these equal to 0. So when we're solving this, it's a true statement if plugging 0 in for p of x helps me to find the zeros. Plugging in 0 for p of x also helps me to find roots. So that is also true. We know that those roots can be x-intercepts, so they can be on the x-axis, here, here, and here. So that's also a true statement. My relative maximums, you can see that there are a couple points that could be my relative maximums. I'm not really sure what the exact points are there, but I do know that p of x is talking about a y value. So if this is talking about y being equal to 0, I know that this point right here does not have a y value of 0. Neither does this point over here. So the relative maximums, that's a false statement, because I can have a relative maximum that does not have a y value of 0. There are certain functions that we can draw where the relative maximum would have a y value of 0, but that's not how you find and solve for a solution to the relative maximum. Same thing for relative minimum. You'll see right here that this relative minimum is actually one of these points we found. So that's a relative minimum. But this is not how you solve for relative minimums in general. If this was somewhere else shifted, that is not how we would get that solution. It just so happened to work out that way. So solutions to p of x equals 0, in this case, it is able to find a relative minimum just because it bounced and came back down. But Be careful on questions like that because that's not always how you find a relative minimum. So we're going to skip over that because it's technically true for this case, but in most cases that's going to be false. My y-intercepts, well, we can see my y-intercept is right here. My y value is not equal to 0 there. My x value is equal to 0 there, and this means p of x equals 0 means the y value is 0, not the x value. So that one's going to be false as well. Moving on to 7 through 12. True or false? The following functions have the same end behavior as the polynomial given. So if they have the same end behavior, let's find the end behavior of this one first. Well, in order to find end behavior, we need to find the degree and the leading coefficient. The degree of this function is the highest exponent. So in standard form, it should always be first. If your polynomial is not written in standard form, you should write it in standard form. So my highest exponent is 5, which is an odd number. And my leading coefficient is the number that is in front of that highest term. So if I have x to the 5th power, the 4 is the leading coefficient. So that is a 4, and the important part of that is that it's a positive number. So we're going to find the left and the right end behavior. We always find the right first, even though we list it second. I list it second in order to show that we always look at the left and then the right next, because we read from left to right. But the leading coefficient tells us where the right side is going. And if your leading coefficient is positive, the right side goes up to positive infinity. The left side is determined both by the right and by the degree. So an odd degree means your two end behaviors have to be opposite. So if the right side is positive, then the left side has to be negative. So we want to find other polynomials that have the same end behavior, which means they'll have both of these properties for the degree and for the leading coefficient. I'm looking for odd degrees with positive leading coefficients. So let's start with leading coefficient because that's the easiest to find. These are all in standard form, so x to the 6th, x to the 5th. You'll notice that on all of these my x values decrease as I go to the right. That is standard form. If my leading coefficient is positive, then I can't have number 10 or 12, which makes those two statements false. A positive leading coefficient makes a positive right side end behavior. A negative leading coefficient makes a negative left side end behavior. So those end behaviors would be different than what the question I'm given. The next thing I want to look at is, since these are all positive leading coefficients, I want to check to see, are both sides going to positive infinity or is only one side? So on my example, my end behavior goes in different directions. But if I had an even degree, like this 6 right here, since the degree is 6 on problem number 7, these two end behaviors would go in the same direction, meaning they would go to positive infinity and positive infinity. That's not the same as negative and positive. So that one is also false. So let's check the next one. I have a positive leading coefficient with an odd degree. That one's true. Positive leading coefficient with an odd degree. Positive leading coefficient with an odd degree. The three correct answers are 8, 9, and 11. Moving down to 13 through 19, which of the following could be a graph of a of x to the 4th plus b of x cubed plus c of x squared plus d of x plus e, where a is not equal to 0? If a was equal to 0, we wouldn't have a 4th degree, we would have a 3rd degree polynomial. But a can't be 0. It can be a positive number, like 2x to the 4th. It can be a negative number, like negative 3x to the 4th. All of these other letters can even be 0, but a cannot be 0. So if I had all these other letters equal to 0, this is what my functions would look like. But I could also have them be other numbers, and I could add on more terms. So let's check to see which of these would match. Well, we know most quartics are a W shape because they have 4 turns. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. We know that A can't be 0, but it can be positive and it can be negative, so it doesn't matter between those. So it doesn't matter whether it opens up or opens down as long as it's quartic. So 13, 15, and 17 are all true. Let's take a look at 16 and 18 next. 16 and 18, their end behavior goes in opposite directions. We know that opposite means an odd degree. 4 is an even number. So 16 and 18 have to be false because they are opposite directions, which means their degree is odd. 14 and 19 were tricky. Some of you might have put certain answers based off of what it looked like. It looks quadratic. It may be quadratic, but it may not be. It might be quartic. If you look back at your Unit 1 notes and when we were looking at Desmos, or even if you typed negative 3x to the 4th on Desmos, or positive or negative number, these are both negative because they're going down. Some of these, it says which one could be a graph to the solution. It's okay. So we have, when we have x to the 4th and we don't have anything added to it, that means if my function has an x to the 4th, that means my 0, when I plug in 0 for f of x, I also get 0 for x. And this 4 means that 0 of my function is happening 4 different times. So it could be a bounce, which means it just slows down as we get to that value. So we are not really sure. So what we're doing on this problem is just looking at the end behavior. So the end behavior of 14 and 19 is the same as the end behavior on 17. It's a 4th degree polynomial. I don't know if these are 4th degree or 2nd degree because we're not really told. They could be a 6th degree. So it's a what could be the graph, and it could have this shape. So as long as you're looking at the end behavior on 13 through 19, you should get the correct answer. So opposite would mean odd. We want even degree polynomials, so they have to go in the same direction. So we're going to say true for 14 and 19 because it is possible that those are quartic, and you can always plug in an example on Desmos to confirm that at home. Numbers 20 through 24. Choose all of the following that are factors if x minus 6 is a factor of x cubed minus 3x squared minus 16x minus 12. So if x minus 6 is a factor, that makes our job easier because we're going from x cubed minus 3x squared minus 16x minus 12. And the next step will have an x minus 6 in it. So if I have one x out here, I need to have an x squared inside this second set of parentheses in order to multiply to get to x to the 3rd power. I can do some other deductions based off of what kind of numbers need to be inside here to get a negative 12 maybe. And there's a lot of things that can help me, but if you're ever given a factor, you can use either long division or synthetic division to divide that factor out in order to determine your second factor. So I'm going to do that. If x minus 6 is a factor, in order to divide by x minus 6, I need to find my 0 of my function. So if x minus 6 is a factor, a 0 is x equals 6, and I'm going to use that 6 for synthetic division. You can use long division. When you're using long division, you're going to use the entire factor of x minus 6. So over here, I'm going to write down my coefficients because that's what we do in synthetic division. We have a 1 in front of x cubed, a negative 3 in front of x squared, a negative 16, and a negative 12. So we always bring down the 1. I'm going to multiply 6 times 1 is 6. And then you're going to add the terms that are inside this symbol. So negative 3 plus 6 is 3. Again, on the outside I'm going to multiply, and on the inside I'm going to add. So multiply to 18, add to 2. Negative 16 plus 18 is 2. Multiply to 12, add, and we get 0 because those are opposite numbers. That last number is always going to be your remainder. If you're already told that x minus 6 is a factor, you should get 0 as a remainder. But these three numbers help us to write our polynomial. The last one is our constant. The first one is going to have an x, and the second one is going to have an x squared, but I'm going from right to left to determine that. Okay, so the first one from left to right, we said has an x squared, so that's 1x squared, which I can just write as x squared. The next one is positive 3x, so we write plus 3x. And then my constant is a positive 2. This is a good sign because the negative 6 times the positive 2 will eventually give me a negative 12. And these other numbers are going to help me out somewhere along the road as well. Alright, but this is not completely factored. I have a binomial and a trinomial. I need to see if that trinomial is factorable. So in order to factor that, we multiply our first times our last term. X squared times 2 gives me 2x squared. And my middle term goes down below. I know that 2x times 1x would give me 2x squared. 2x plus 1x would give me 3x. So we're going to replace this 3x with 2x and 1x. And then we're going to factor by grouping. Whenever you have 4 terms, you can check to see if you're able to factor by grouping. We'd split it in half, and out of the first 2 terms, I have a greatest common factor of x. Out of the second 2 terms, there's no greatest common factor, which means there actually is a greatest common factor of 1. So then that leaves me with x plus 2 inside the parentheses. If these binomials match, and they do, you can factor that out to the front. If they don't match, then you cannot factor by grouping. You would have to factor using synthetic division if you're given a factor. But on this test, you will always be able to factor by grouping unless you're given a factor to divide by. So x plus 2 and x plus 1, I factor out the x plus 2 to the front. The x plus 1 is the one left over, but I also still have the factor of x minus 6, which is still part of my answer. So x cubed minus 3x squared minus 16x minus 12 factors to x minus 6 times x plus 2 times x plus 1, which means yes, x plus 1 is one of my factors. X minus 12 is not one of my factors. X plus 3 is not one of my factors. X plus 2 is one of my factors, and x minus 6 is one of my factors. Which of the following functions could be represented by the graph? Select one best response. So there's only one answer on these, so you want to narrow it down as much as you can. So we'll start with our x-intercepts. I have 3 x-intercepts. X equals 1, x equals 2, and x equals negative 1. In order to create binomials, those x-intercepts are zeros of my function. So if I set this equal to 0, I'm going to add the 1 to the other side in order to get 0. Subtract this 1 to the other side in order to get 0, and subtract the 2 to the other side in order to get 0. I've now created my zeros of my function, which mean I have now been given 3 factors that are part of my answer. So this polynomial is named g of x based off of the multiple choice questions. I don't know the a value yet. I have to solve for the a value at the very end. But I do know my 3 factors. So x plus 1 is a factor, x minus 1 is a factor, and x minus 2 is a factor. But you'll notice that I have an x plus 1 times an x minus 1 times an x minus 2. X times x times x is x to the 3rd power. If I have a 3rd degree polynomial, it would go in, the end behavior would go in opposite directions, no matter what they are. If it's negative to positive or positive to negative, doesn't matter, would go in opposite directions. This is an even degree function because it goes in the same direction, which means I need to check to see if one of these has a higher multiplicity. So a pass means an odd multiplicity, but a bounce means an even multiplicity. So this bounce right here means that my factor of x minus 1 has to have an even exponent. So I'm going to raise that to the 2nd power. You'll notice on the left-hand side, some of my x minus 1s have been raised to the 2nd power and some of them have not. The x plus 1 on this side got raised to the 2nd power. That one's wrong. Make sure you write your bounce correctly. The x minus 1 is raised to the 2nd power here, not here. The negative, let's see, x minus 1 is raised to the 2nd power there and there. So the other thing I need to check is my a value. Most of you can tell by the direction of the function whether it's positive or negative. So if this is opening down, I need a negative a value. Well, that just got rid of another answer because b would go to positive infinity in both directions, but this has negative infinity on both sides. So it's either D or E, but we have to find the specific a value to find the correct answer. So in order to do that, we have one more point we haven't used yet. This point is the y-intercept of 0, 3. 0 is my x value, 3 is my y value. I'm going to plug in my 0 for all my x's and my 3 for g of x. And then we can start to solve. Parentheses first, we're going to do 0 plus 1 is 1. 0 minus 1 is negative 1. And 0 minus 2 is negative 2. I still have the a out in front and the 3 on the other side, the equal sign. Since these are all in parentheses, that means I'm going to multiply them together, but I'm going to do the exponent first. So negative 1 squared is positive 1. 1 times negative 2 is negative 2. Negative 2 times a is negative 2a. In order to solve for a, we're going to divide by negative 2 on each side. And you'll see that negative 3 over 2 is our a value, which means my correct answer is E. So D is not correct because it doesn't have the correct a value. How many distinct x-intercepts does each function have? So on 26 through 28, you'll have to make sure that they are completely factored in order to find your x-intercepts. Otherwise, you just need to make sure when you're taking a square root of something that you do plus or minus. But I just go ahead and write these out completely factored. So I have g of x equals x squared plus 5 is not a difference of squares, so I can't factor that more. X squared minus 4 is a difference of squares, so that factors to x plus 2 times x minus 2. For the next one, again, x plus 5 is completely factored because it only has to 1 x to the first power. But I can factor x squared minus 9 to x plus 3 times x minus 3. 3 is the square root of 9. And then the last one, I cannot factor x squared plus 9 anymore because it's not subtraction. In order to be difference of squares, it has to be subtraction, not addition. But the next one, x squared minus 1, is a difference of squares, so that factors to x plus 1 times x minus 1. And my last one is x plus 3. And notice, this only goes up to 4 intercepts. You can't have more than 4 because these are our answer choices. So this last one, you may have thought 1, 2, 3, 4, 5, 6, 7. I don't know. You might think that there's a lot more. Even if you only count each of these once, 1, 2, 3, 4, 5. 5 would be too many x-intercepts. So which binomial does not give us x-intercepts? This value right here. If I plug in a -3 and then add 3, I'm going to get 0, and 0 squared is 0. So this one will be -3, 0. That's one of my x-intercepts. If I plug in a positive 1 and then subtract 1, that's an x-intercept. This one will be -1, 0. What number do you plug in and then square it, add 9, and get 0? Well, if you plug in 3, 3 squared is 9. 9 plus 9 is 18, not 0. If you plug in -3, -3 squared is 9. Plus 9 is 18, not 0. So even if you plug in a -3 here, you're going to get a positive answer. So let's come back to that one, and we'll set it equal to 0 in order to solve for it. What number do you plug in for x to get 0 for x squared? If you're not sure about that one, we're also going to set that one equal to 0. So x squared equals 0. We're going to solve that. And we're going to solve for x squared plus 9 equals 0. Remember, I'm setting all of these equal to 0 to find these points. Some of them are just easier done in your head. So right here, I need to take the square root of each side. And the square root of 0 is 0. So that gives me another x-intercept at 0, 0. I already have 4, so the odds are my answer is going to be E. But let me show you why x squared plus 9 doesn't work, because that'll help us on some other pieces. So we're going to subtract 9 from each side. And then we're going to take the square root. And when we take a square root, we take plus or minus. So the square root of 9 is 3. But the square root of -9 is 3i. And if I'm taking plus or minus the square root, this is going to give me plus or minus 3i. This is a 0 of my function. Good. We found two zeros, positive 3i and negative 3i. But I cannot plot these as x-intercepts. What's the difference between the x-intercept and the 0 here? Well, zeros you can solve for. But an x-intercept is a real 0. So when it says how many distinct x-intercepts, you need to remember that they need to be real numbers for answers. And positive 3i and negative 3i are not real numbers. So the other ones that I have 4 x-intercepts, so that's E. Alright, so on number 27, I don't have another x squared plus a number. I have an x plus 5 squared, but I know that I can plug -5 in. -5 plus 5 is 0, and 0 squared is still 0. So -5 I can plug in, -3 I can plug in, and positive 3. Don't forget that you can also plug in 0 for x in order to make all these equal to 0. So number 27 also has 4 x-intercepts. 0, -5, -3, and positive 3. 26, I can plug in 2 and -2 to get 0. But right here, when I get x squared plus 5 equals 0, subtract the 5 to the other side, I'm going to get another imaginary number, because when you take the square root of a negative number, that gives you an imaginary number. So these are going to give me imaginary solutions for x squared plus 5. But these other two gave me real numbers, positive 2 and negative 2. So this is C. That one has 2 x-intercepts. All right, number 29. F minus g of x is the same as writing m of x equals f of x minus g of x. So we're going to take f of x and subtract g of x. When you do that, don't forget to put your second polynomial in parentheses. So m of x is equal to x cubed plus 4x squared minus parentheses 9x plus 36. I have two options right here. I could distribute that negative and then factor everything out, or I could just factor it by grouping right now. I'm just going to group the other two together. So my greatest common factor out of the right-hand side is a negative 9. Just kidding. My greatest common factor on the right-hand side is a positive 9, because those are both positive numbers. But I already have a negative out in front, so don't forget the negative is already there when you factor it out. All right, 9 times x is 9x. 9 times 4 is 36. We're not going to get the negative part because the negative was already outside. So if you distribute this back in, just check with the 9. And then the negative will match from up here. On the left-hand side, the greatest common factor is x squared, and I'm also left with x plus 4. Okay, now my greatest common factor is x plus 4, and that leaves me with x squared minus 9. This x squared minus 9 is a difference of squares, so it factors to x plus 3 times x minus 3. But I already have an x plus 4 from prior, and I need to write this as an equation because this started as an equation. So m of x equals x plus 4 times x plus 3 times x minus 3. This is my final answer. And part B says to find all the zeros. So I need to plug in 0 for m of x, which means my zero product property, I set each of these equal to 0 and I solve. So when x plus 4 equals 0, x would equal negative 4. When x plus 3 equals 0, x would equal negative 3. And then when x minus 3 equals 0, x would equal positive 3. Or you can just tell me what numbers you plug in there. So in order to list out the zeros, you can list them as points. These would be negative 4, 0, negative 3, 0, and 3, 0. Or you can tell me x is equal to, sorry, this is set notation, negative 4, negative 3, or positive 3. All right. On number 30, make sure you have x to the 5th minus 50x to the 3rd power, there's a typo there, plus 49x. First, we're going to factor out a greatest common factor, which is x, and that leaves me with x to the 4th minus 50x squared plus 49. Because my middle term has half as many x's as my first term does, I can factor this trinomial by grouping. So I'm going to multiply my first times my last, which gives me 49x to the 4th. And then I want to know what two terms multiply to 49x to the 4th and add to negative 50x squared. The number part is easy. Negative 49 and negative 1 multiply to positive 49 and add to negative 50. But what's my variable if they have to add to x squared and multiply to x to the 4th? We know like terms means if you add these together, your like term is going to stay the same. So these should match my like term down at the bottom. X to the fourth stays the same. Negative 50x squared is going to be replaced with the two numbers we just found. Don't forget that this x is out in front. We're going to put that in our answer at the very end, but just so that we don't lose it, I'm going to keep it out front. Don't use it when you're factoring by grouping though, because you're factoring these four terms by grouping. So we're going to look at the left two terms. My greatest common factor out of the left two terms is x squared, and I'm left with x squared minus 49. My greatest common factor out of the right two terms is a negative 1. Whenever that first term's negative, go ahead and factor out a negative, and I'm left with x squared minus 49. This was everything inside my parentheses, so I'm going to go ahead and put a bracket around it now since I already have parentheses in here. This x is still outside, the g of x is out in front, it's still an equation. I'm not quite done until everything's completely factored. X squared minus 49 is my greatest common factor now. So I'm going to factor the x squared minus 49 out. And that leaves me with x squared minus 1. Still not completely factored. Both of these are difference of squares problems. So this problem, I'm just going to change this to an A so we can write it in a blank. My answer would be g of x equals x times, well, x squared minus 49 is a difference of squares, so it factors to x plus 7 times x minus 7. And x squared minus 1 is a difference of squares, so it factors to x plus 1 times x minus 1. That's a lot of factors. 5 factors for this problem, which is good because I have x to the 5th power, so we want to make sure our degree stays the same. But for part B, I need to solve for what would make g of x equal 0. So if I plug in 0 for this g of x, what x values could I plug in to make that equal to 0? Well, you could plug in 0 for x. You could plug in negative 7. You could plug in positive 7. You plug in negative 1, or you can plug in positive 1. So those are all of your solutions that x could be. That's the answer to part B. All right, number 31. For the given function, completely factor over the integers and find all of the zeros. And you're given a hint. You can use long division on this, or synthetic division can be used every time you use long division. Anytime that you can use long division, you may use synthetic division instead. So if we're given a factor, we know that our 0 is x equals 4. If you're to find all the zeros, that better be one of your answers on part B, because that is a 0. So if I use synthetic division to factor this, I'm going to write in all of my coefficients: 1, negative 7, 8, and 16. I didn't skip over any terms, so we're good. We don't need to put any 0 placeholders in. Bring down the 1. 4 times 1 is 4. Negative 7 plus 4 is negative 3. 4 times negative 3 is negative 12. 8 plus negative 12 is negative 4. 4 times negative 4 is negative 16, and 16 plus negative 16 is 0, which is good. My remainder should be 0 if I'm given a factor. This polynomial right here is x squared minus 3x minus 4. You start from the coefficient, and then going to the left, you increase one x value each time. I'm sorry, not the coefficient, the constant. Constant doesn't have an x. It's x to the 0. But we know one of my factors was the factor I just factored out of x minus 4. And then x squared minus 3x minus 4 can be factored as well. I'm going to use grouping in order to factor x squared. Let's see. I'm going to use this as a separate sheet of paper so I can show room. To factor x squared minus 3x minus 4, I need to know what two numbers multiply to negative 4x squared and add to negative 3x. Those numbers are negative 4x and positive 1x. They multiply to negative 4 and they add to negative 3. I'm going to replace the 3x with those two terms. Remember, you replace this negative 3x with the two terms you just found, which are negative 4x and positive 1x. Then, out of the left two terms, I'm going to find my greatest common factor, which is x, and that leaves me with x minus 4. My greatest common factor out of the right-hand side is positive 1, and that leaves me with x minus 4. My x minus 4 is now my greatest common factor, and that leaves me with x plus 1. So, this is equal to x minus 4 times this x minus 4 times x plus 1. Please write out your answer as g of x equals each of your factors. X minus 4 times x minus 4, since there are two of them, I can write it as x minus 4 squared. And then the x plus 1 will follow. This now means I only have two distinct x-intercepts. Positive 4 and negative 1. You could also write them as, or you, instead of writing them as set notation, you could have written them as 4, 0, negative 1, 0. That's fine as well. These would be your 2 points on your x-axis. So now that we've done all that work to plot points, we need to actually practice graphing. You need to make sure that your polynomial is completely factored in order to graph the function. So this first function is already completely factored. The next one is already completely factored. This last one is not completely factored. I have a trinomial that I'll be able to factor. But it's easy once it's already factored, because I'm going to, in order to find my x-intercepts, I'm going to plug in 0 for f of x and find the places where I can have an x value in order to get 0. So 3 minus 3 would give me 0. 0 times anything would give me 0. So whatever numbers you can plug in here to get 0 will give you x-intercepts. I'm going to set each of them equal to 0 to show that that's what we're solving. Take the square root on each side and you get x equals 0. X plus 5. If x plus 5 equals 0, then we subtract 5 from each side and you get x equals negative 5. And x minus 3. If you set x minus 3 equal to 0, you can add 3 to each side to get a positive 3. So those are the three x values that I have where my f of x equals 0, which means those are my three x-intercepts, because that's my x value and my y value is 0. Left 5, up 0. And then this 0 will be the point 0, 0. So I have three distinct x-intercepts. But we need to look at the degree of our function and the leading coefficient in order to determine the end behavior. We also needed to look at the degree of each factor in order to determine if any of my zeros have a higher multiplicity than 1. So starting with the degree. This degree is x squared times x, which is x to the 4th. My degree is 4, which is an even number. That tells me my end behavior should go in the same direction. My leading coefficient x squared times x gives me x to the fourth, which means there's a 1 in front of x to the fourth. My leading coefficient is 1. And that positive 1 tells me my right side's going to go to positive infinity, and if it's even, the left side has to go in the same direction, so that's also positive infinity. You can draw those in first if you would like. You need to also find your y-intercept. But we already have our y-intercept because we have this point of 0, 0. So when x equals 0, y is going to equal 0. So one of these needs to bounce in order for me to draw this incorrectly. So I go up here and look at my factored form. This binomial is to the first power. This binomial, or factor, is to the first power. The first factor is to the second power, so that one is going to be my bounce because of that x squared. So we're going to bounce off 0, 0. Everything else is going to be a pass. And then I have that W shape where I have a bounce at 0, 0. 33, we're going to do the same thing. I'm going to go through it a little bit more quickly because it's the same process. You're setting f of x equal to 0, which means you want to find which x values make this entire equation equal 0, which is basically what number can you plug in for x here to get 0. So that's a positive 1. This number is going to be negative 3, because if I plugged in negative 3, my plus 3 would give me 0. And positive 4 minus 4 would also give me 0. My degree of this function is x times x times x, which is x to the third. My degree is 3. My leading coefficient is the number out in front, which would be a 1. My end behavior on the right will match my leading coefficient. So if that's positive, this goes to positive infinity. The left side, I have to look at the degree and the right side. So an odd degree means that these are going to go opposite directions. So if the right is positive, then the left is negative. Okay. At this point, I don't know where I'm crossing my y-axis. So you have to find the y-intercept on this problem, and you have to label it on your graph. So in order to find the y-intercept, I'm going to plug in 0 for x. So to the first equation, I get f of x. I'm going to make myself some more room. Still plugging in 0 for x. I'm going to do f of x equals 0 minus 1 times 0 plus 3 times 0 minus 4. So when I plug in 0, I get negative 1 times 3 times negative 4, which is negative 3 times negative 4, which is a positive 12. So I need to label that point positive 12, which is my y-intercept. You can do 0, 12, or you can just label the 12 there. Now we can draw in the rest of our function, and I had no bounces because all of these factors are to the first power. Only even degrees will bounce. Number 34. F of x equals g times h of x. So I'm going to have to multiply these two together. So f of x is going to equal g of x, write that out first, times h of x. We know that if two things in parentheses are written next to each other, that means to multiply. So this is almost in factored form. I just need to factor this trinomial. So what two terms multiply to 8x squared and add to negative 2x? Let's see, negative 4x and positive 2x. Negative 4 times positive 2 is negative 8. Negative 4 plus 2 is negative 2. So I'm going to replace my middle term here with -4 and +2. So x squared minus 4x plus 2x minus 8. My two terms on the left-hand side, my greatest common factor is x, and I'm left with x minus 4. On the right-hand side, my greatest common factor is +2, and I'm left with x minus 4. Out of these two terms, my greatest common factor is x minus 4, and I'm left with x plus 2. Bring everything else down. -1/2 is a factor. X plus 1 is a factor. So I have 4 factors, but only 3 of them have x values in them. So x times x times x is a degree of 3, which means my end behavior is going to go in opposite directions. My leading coefficient, x times x times x times -1/2, is going to give me -1/2 x cubed. So my leading coefficient is -1/2, which is a negative number. My right, let's do left, right, there we go. My right side is going to go to -infinity because my leading coefficient is negative. My left side will be opposite of my right because my degree is odd. We still need to find the y-intercept and the x-intercepts. So let's start with x-intercepts. What numbers can we plug in for these 3 x's to make everything equal 0? That is a -1. Plug in a +4, 4 minus 4. Plug in a -2, and I have my 3 x-intercepts here. My -1, 4, -2. My y-intercept I get from plugging in 0 for x. So I have f of x equals, you have to plug it in when you write out f of x. So either to this entire equation or this one. I would suggest plugging it in here, but you don't have to. So if I plug in 0 for each of these, I get +1. 0 minus 4 is -4. And 0 plus 2 is +2. So this is negative times a negative, or sorry, negative times positive times negative times positive. I'm in -1/2 times 1 is -1/2. -1/2 times -4 is +2, and 2 times 2 is 4. So when I get f of x equals 4, or I should say f of 0 equals 4, because I plugged in 0 for x, then I get the point 0.04. The right side needs to go to negative, the left side needs to go to positive. All of these are to the first degree, x to the first, or each factor is to the first power. So none of them are bounces. That's what my function looks like. Okay, number 35. The graph of a polynomial function is given below with 5 key points labeled. Sketch the following transformations of y equals f of x and label the locations of the 5 key points. So whenever you have an x plus something or minus something happening inside the parentheses, remember when we talked about vertices and what direction that means that this was translated? This always means if I look at my x value that I would plug in here to get 0, that tells me what direction to go, but it's always opposite of that value. So this means go to the left 4. You're going to take each of these points and shift to the left 4. Please make sure that it changes your x value and not your y value if you're shifting to the left. So see, 1, this would be -4, 0. 2 shifted to the left, 4 would be 1, 2, 3, 4. It would go to -2, 0. This 1 shifted to the left, 4. You're going to subtract 4 from your x value. And that would be -3, -40. Subtract 4 from this x value, and it'll be on the y-axis. And then subtract 4 from 5, and you'll be at +1. So this is 0, 80, and 1, 0. You need to make sure you label all of your points for credit. And then draw in your function as well for credit. All right, moving to the other side. We're using the same points, but this time I don't have something happening to the x inside. We have something happening to the f of x, which means f of x minus 13 means move every point down by 13. So you're going to take this first function and subtract 13 from each of your y values. So those points would be at 0, -13, 1, -53, 2, -13, 3, -67, and no, 4, -67, sorry, and 5, -13. Oh, -13. But the shape of the graph would still be the same. Oh, you can't even see that. I'm so sorry. Okay, the hardest one was this last one, so make sure you can see this. This means the opposite of f of x minus 10. F of x is talking about your y value. So you're going to take the opposite y value and then subtract 10. I'm only going to show you one point on this, so please make sure you're paying attention. Let's do 1, -40. So this is my original point, is 1, -40. I am going to write that point at the top. This is how it started. My new point, my y value needs to be the opposite and then go down 10. But it doesn't say anything is changing about my x value, so that x value is going to stay exactly the same. So my original y value is -40. I want to take the opposite of that, which is +40, and then subtract 10, which is 30. Oh, you can't see that. Okay, one more time. My original point was 1, -40. This means the opposite of y. So I'm going to take the opposite y value, which would give me +40. And then after that, you subtract 10. So think of this as opposite y, then minus 10. I'm going to show you the other point just because you couldn't see that one at first. So the other point is, one of the other points is 480. So the opposite y would be opposite of 80, would be -80, and then minus 10, -80 minus 10 is -90. So my new point is 4, -90. So you're going to do that with every point and then graph them. You should graph a reflection on that. A negative y means you reflect over the y-axis. So if we reflect these first and then shift them down, then my end behavior should have been reflected as well, which means instead of going from positive to negative, I'm now flipped and going from negative to positive. So your graph should look something like this. Okay. Write in factored form the equation of the cubic polynomial with the function f of x. It has a name, so use the name, with zeros, -1, +2, and -3. So if those are zeros, then that means x equals -1, x equals 2, and x equals -3. In order to write them as zeros, I move them to the other side by adding or subtracting. I don't know my a value yet. That's why it gives you a y-intercept, is to find your a value. But using these zeros, I do know my factors. So if x is equal to -1, that means x plus 1 is a factor, because I could plug in that -1 to give me 0. If x equals 2, that means I can subtract 2 to get 0. Or if x equals -3, that means I can add 3 to get 0. So you can add that to the other side or subtract. Now I want to solve for the specific a value. This has a very specific a value. And if you don't use the y-intercept to solve for it, you won't get the correct a value. Or another point on the graph, whatever point is given to you. So like down here, you can use 1, 2 for this graph to find the a value. So this case, I'm given the point -6 for my y value, 0 for my x value. So I'm going to plug in my zeros and plug in -6 for f of x. 0 plus 1 is 1. 0 minus 2 is -2. 0 plus 3 is 3. Then I multiply all these together. 1 times -2 times 3 is -6. So I get -6 equals -6a. If I divide it by -6 on each side, I get a is equal to 1. So now I have solved and got my a value as 1. So this answer is f of x equals 1 times x plus 1 times x minus 2 times x plus 3. You do not have to write the 1 out in front, but you do need to show your work solving for your a value. Number 37, write an equation for the given graph and determine if the leading coefficient a is positive or negative. Again, I'm going to write my zeros of my function. So if this 0 is at -1, then I know that my factor is x plus 1. If this 0 is at 0, I know my factor is x plus 0, or just x is fine. And if this factor is at +2, I know x minus 2 is my factor. So this middle one, whenever you get x plus 0, x plus 0 is just x. So that's a monomial. We always write that one out in front. So this function doesn't have a name, so we can name it whatever we want. We usually use f of x if we're not sure. I don't know the a value yet. I do know that I have 3 factors. X plus 1, and x minus 2. But look at my end behavior. They're going in the same direction, which means it needs to be an even degree. This equation is currently an odd degree. X times x times x is x to the 3rd power. Do any of these happen more than once? Pass, pass, bounce. A bounce means you have to have an even multiplicity. So this exponent has to be to the 2nd power or to the 4th power, something like that. So we're just going to write the lowest one. So if I write it to the 2nd power, I'm going to put a 2 outside the parentheses. And now I need to solve for my a value. So I plug in 2, and I plug in 1 for x, 1 plus 1, 1 minus 2 squared. So I'm plugging in the 1 for x, 1, 2, 3, and plugging the 2 for y, which is just once. Alright, so that gives me a times 1 times 2 times negative 1 squared. So 1 minus 2 is negative 1. Negative 1 squared is positive 1. So I get a times 1 times 2 times 1 is 2a. Divide by 2 on each side, and I get a is equal to 1. So my a value is 1. So I'm going to write f of x is 1x times x plus 1 times x minus 2 squared. It says determine if the leading coefficient is positive or negative. You're going to put the leading coefficient is positive. As long as you write a positive 1 or a 1 out in front, or you just have your x out in front, you should be able to write that correctly. This has been the practice test for Unit 3. If you have any questions, please make sure you ask at lunch or in class.